Tech support. Network down? Uh-huh. Are you sure? I know a guy.
Sudoku's hard.
Mike, the network's down. You've got to teach these kids Network Plus and get it up.
Look, boss, I just don't know if I've got it anymore. I think I've lost that touch.
I want you to put that hat on, get out there, and teach these folks Network Plus.
Let's do it. To normal people, even a simple network rack like the one I'm standing in front of can be intimidating. But I'm a network guy. I love this stuff and I work on it every day. Hi, my name's Mike Myers, and I'll be your guide through the Total Seminars License to Tech Network Plus series. Now, for those of you who are unaware, the Network Plus is a certification that's administered by the Computing Technology Industry Association, better known as CompTIA. If you want to get Network Plus certified, you have to take the Network Plus test. So to take the test, you go to your local Pearson VUE Testing Center, you sit down in front of a computer, you take the test, and if you pass, ta-da, you are a Network Plus certified technician. My job is to give you the knowledge to make sure that you can pass the test. So that's what this video series is all about. This series gives you the knowledge you need to pass the Network Plus. However, there are some ancillary materials that I'd like to recommend to you that you can use together with the video to make all this happen. The first is my book. This is my Network Plus book, published by McGraw-Hill and available at better bookstores everywhere. This actually works with the video series, and you can have a book and a video, and they work well together. A lot of people like this. Second are my Total Tester. The Total Tester is a test bank of practice questions that give you a strong feel of what the Network Plus is all about. Third are my Total Sims. There's a number of questions on the Network Plus that are designed to act as simulations. So they're really looking at how you perform on certain situations. So these types of performance-based questions really require a separate tool, and that's where my Total Sims come into play. The Total Sims are an online product. You just go through and they give you lots of cool simulations and situations just like you'll see on the Network Plus. So, welcome to the video series. The biggest challenge of learning networking is the fact that, well, networking is incredibly complicated today. Now, complicated is good. Complicated means convenient. For example, I could fire up my iPhone and I can get right onto the internet and check the traffic, whatever I need to do. My TV in my house is connected to the internet, and I can do Netflix and all kinds of cool stuff. Even in my house, the electric meter on the back of my house is connected to the internet. So networking today, because of the internet, is fabulously complicated. Well, complicated is good, but it's not a good way to learn about networking. So to appreciate networking, what I want to do is simplify things a little bit. Let's go back in time. And to do that, I want to show you these old guys here. This is a NIC, or a network interface card. Traditionally, these are plugged into individual computers, and then we use this big chunk of cable right here to connect to a box, which at least for the moment, I'm going to call a hub. This box acts as the interface to allow lots of computers, well, at least in this case, 8 computers, to interconnect with each other so that they can share resources. Now, when I say share resources, a resource can be anything from a web page to a Microsoft Word document to a LAN server playing World of Tanks. It doesn't really matter to me, but it's just something that somebody can share with somebody else. As a matter of fact, because this is only local, this is where the term local area network came from. We'll develop that more in other episodes in this series, but for now that'll work. Now, the thing is that if I've got all of these computers connected to each other, how are they actually sending data? if I've got one computer with a Microsoft Word document and I've got another computer where that person wants to access that Microsoft Word document, how does the data actually move through all these little cables? Now, to appreciate how that works, you have to go back a little bit and understand that we're talking about binary data being sent. Now, I don't care if it's a copper cable with electricity going up and down, or if it's a fiber optic cable with light turning on or off, or even if it's a wireless network where radio frequency basically says on and off, it's always ones and zeros on and off. So if you really want to see data being moved along these cables, it looks kind of like this. Wow, that's really good there. The idea is that it's kind of like a Morse code that's being sent between devices. And these devices understand that code, and they can actually do things with it, like recreate a Microsoft Word document or whatever it might be. Now, the thing you really need to appreciate, and this is the cornerstone of everything that's networking, if there's one thing I'm going to make sure you understand before you run away, is that this data is not sent in big, long, continuous streams. It's sent in discrete chunks that are called, traditionally they're called frames, although you hear the word packets as well. And again, there is some difference, and in other episodes in the series will qualify that. So if you really want to understand what's going on, what I need you to do is visualize discrete chunks of ones and zeros that are flying back and forth across your wires on your network. So they look, if you want to see what a frame looks like, it looks something, well, kind of like this. These big stream of ones and zeros that are running across the screen, now notice that they start and then they stop and then another chunk comes along and another chunk, are what frames really are. And we call this packetized data. So in order to appreciate packetized data, and trust me, packetized data is the cornerstone of networking, we need to do something to analogize the concept a little bit. And, well, I like to play, so let's use some blocks. Yay, fun blocks to play with. Now, this block is going to represent a frame. So let's bring our frame back here. Okay, now, if you take a look at this frame, you'll notice it's all the ones and zeros like we saw before. Now, the thing you need to appreciate is that a single frame can be up to 1,500 bytes long. So if there's 8 bits to a byte, so that would be just around 10,000 ones and zeros to represent one single frame. So if we scale this down a little bit, yeah, you can't even see the ones and zeros, so because frames are relatively long, so that's just how they show up. And that's part of why we use these little blocks to represent individual frames. So a frame is actually generated inside the network card. Data comes down from whatever applications, Microsoft Word or web browsers or whatever it might be, comes down into the network card itself. The network card creates the frame and shoots it out into the network. Equally, frames are eaten up by network cards. As a frame comes into a network card, the data is pulled away, sent up to whatever software needs it, and then it's actually wiped out within the network card itself. So, to appreciate a frame, what we need to understand is that we use blocks like this as a representation. Frames are always going to be a maximum of 1,500 bytes, and they have a discrete beginning and a discrete end. And remember, frames are created and eaten up within the network card itself. Frames are a fantastic way to make data move around. The problem is how do frames know how to get to the right computer? So if you take a look at a network, what we have here is a hub. Now on this hub, if I'm sending data, it's coming in from the white cable. When it gets inside the hub is what we call a repeater. It takes the signal that comes in from one of the ports, and then it recreates multiple copies of that and sends it out on all of the other connected cables. So it literally takes one signal and repeats it out to as many connections as you have. Now that creates a big problem. The challenge we have here is I've got a network, all right? So this is going to be 4 computers that are connected to a single hub. The challenge that we have is that, let's say that this purple computer wants to talk to the green computer. What's going to be taking place is that when this purple computer sends out a frame, it gets sent into the hub, and the hub, remember, repeats it out to all of the connections. So everybody gets an example of that frame. Now that frame isn't for everybody, it's just for the green computer. So we need some way to address each of the frames so that even though everybody gets it, only the green computer is actually going to read the frame and use it. These other 2 guys, when that frame comes in, they're going to see that it's not for them, and then they'll just wipe it out or consume it so it never goes past the network card. So in order to do that, I want to make an analogy of a network card as a tray. So this, for me, I'm having a little fun here, is a network card. This ugly old vacuum tube from my shop vac is the RJ45, the wired connection into it. So when a frame comes in, it literally plops down and the network card looks at it. Now the problem is there's nothing within that network card that identifies it and says it's for this network card, for this particular machine. And that's where something called a MAC address comes into play. In order to appreciate a MAC address, we're going to have to take a look at a computer. So what I'm going to do is fire up my Windows computer, and let's take a direct, close, personal look at a MAC address. All right, now here I am in good old Windows 8. I'm at a command prompt. By the way, what I'm doing here, even though I'm using Windows 8, will work in Windows 7, Windows Vista, Windows XP. In fact, it would probably work in just about every version of Windows there are. So let's go ahead and run a magical command you need to know for the Network Plus. It's called ipconfig. Now, when you type ipconfig by itself, it gives you all kinds of interesting IP information. But in order to see the MAC address, we have to type ipconfig/all. Make sure you know this for the test. So as we run this, you'll notice I have lots and lots of network cards in this computer. That's just the way things go these days. So what I'm looking for is the actual network card that's working for a living. And right now I'm hooked up wirelessly. So here it says wireless LAN adapter Wi-Fi. Now as we go down through here a little bit, what I want you to find is right here. Do you see this? That is your physical address. Now this isn't hexadecimal, so each one of these characters represents 4 binary characters. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hexadecimal characters. So 12 times 4 is 48 bits. So MAC addresses traditionally are always going to be 48 bits. Now, what I want to do is have you take a look at this. And as you look at this, you'll notice that it's broken up into groups of 2. All right? The first 3 groups of 2 are actually issued to the manufacturer. So Broadcom, who's the maker of this particular wireless NIC, they own the 70-F1-A1. And that's what we call the OEM part of the MAC address. The second part is the unique identifier. Once Broadcom is issued the first half of the MAC addresses, it puts a different set of numbers on every individual network card it owns. So the thing we need to remember is that every network card in existence has a unique MAC address. It has to have that because we never know on our network here whose network cards are going to be plugged in. And it's the MAC addresses that we apply to the frame to make sure it gets delivered to the right place. So each one of these computers has a unique MAC address. So what we'll do, let's take a look at our frame again, is we're going to add to the frame MAC addresses. Now, I've got 2 blocks here, and that's because we have the MAC address where it's going to and the MAC address of where it's coming from. So whenever your network card sends out a chunk of data, it's very important to the network card that not only does it know where to send it to, but it also will put its own MAC address in there so the receiving computer can send it back. Now, the other thing that will come into play here is a CRC, or a cyclic redundancy check. This is just used as a way to verify that the data is good. If it's bad data, then it knows to resend it. So what we'll do, let me go ahead and get it pointing in the right direction, is once this is all created, it gets sent out. I'm not going to push it through too far because I'll never get it back. But push, off it goes off to the network. Now, the cool part to all this is that as it leaves this computer and comes into the hub, remember that the hub creates as many copies as necessary to represent all the different computers it's connected to. So it makes, in this case, 1, 2, 3 new copies, and it sends them down the line to all the individual computers, and as these frames come into the computer, boop, it drops down on the tray. And the cool part is that every network card knows what its MAC address is. So the card looks at this. If it's a MAC address for him, then it's going to strip away all this extra information and send it up into the software of the system. However, if it's a MAC address that's not for him, he'll look at it, see it's not his MAC address, and he just makes it disappear and doesn't do anything with it. And that is how MAC addresses work.